So good morning, everyone. Today we are going to talk about the scheduling algorithm. And the scheduling algorithm that we are going to see today is the priority scheduling, which comes under the category of preemptive scheduling algorithm. So let's try to take an algorithm like a numerical to understand the working of priority scheduling. So if you see here in the previous examples and the algorithms where we talk about FCFS and other algorithms and numericals, we were only seeing the burst time and the arrival time. But in the priority scheduling, we will also see something called as the priority. So that means we try to give a priority to every process, who is the highest priority and who is the lowest priority. So always remember, whenever you have a question for solving, you always try to see what is the criteria and what is the mode for solving. So the criteria for solving here is higher the number, higher the priority. So that means if you have a high number, that means it is a high priority task and you need to finish that task first before the other priority task. So the criteria could also be smaller the number and higher the priority, or higher the number, smaller the priority. So you have to always check the criteria before solving any of the numericals. And the mode is preemptive. So preemptive, as we said, the processes, the CPU will stop the processes in between and then try to execute some priority processes. Now, in order to solve this, let's try to understand the working principle. Now, to understand its working, let's try to see at 0th interval of time. Do you have any process at 0th interval of time that is running? Yes. So you have at 0th interval, you actually have process P1 that have arrived. So the process P1 have actually arrived here, and then it will try to execute at 1 unit of time. Although it needs 5 unit of times to be executed, but we will only execute 1. To be on safe side, I will always suggest you always run all the processes 1 by 1. That means every unit of time. So each unit of time, you just execute the process. Otherwise, you will make a mistake. Once you get the clarity and understanding, then you can skip and then try to run at a bigger burst time. So what we will do, so the process P1 have come, and from 0 to 1, we will try to run it for 1 time. So the burst time have become of process P1 from 5 to 4 now. Okay. Now if you see at interval 1, you already have another process that have arrived. So process P2 have already arrived here. So the process P2 have already arrived at here. Okay. And what is the priority? You see the priority, we already said higher the number, higher the priority. That means 20 is higher than 10. So P2 will get executed now. So the P2 will get now the execution. So when the P2 will get executed, so it will again execute only for 1 unit of cycle. So it will become here 3. Okay. Now, between 1 to 2, when it was the process 2 was getting executed, at the second cycle, you also have the process P3 that have also arrived. When the process P3 have also arrived, then what will happen? Then the process will check whether it is higher priority or not. So if you see like process P3 is having the priority 30, that means it is higher the priority and higher the number. So since the number is very high in comparison to process 1, process 2, and process 3, so it will execute process 3 here. So you execute process 3 here for 1 cycle. You will just execute for 1 cycle here. Let me just rewrite it. Okay, so it have now executed for 1. Now at 3, did any other new process have arrived? So if you notice, the new process has not arrived yet. So the process P4 will arrive at 4. So then the process P3 will continue because the P3 is having the highest priority. So the P3 will again continue for one more unit of cycle. So after that, so the P2 will actually get completed. Sorry, P3 will get completed and then terminate from the queue. Now, if you notice at 4 unit of time, you have the process P4 that have arrived. So the process P4 have arrived here. So when the process P4 have arrived, so and it is having the priority of 40, that means it is having the highest priority. So it will first execute here at P4 and then it will execute for how long? It only needs to execute for one cycle. So once it executes for one cycle, P4 also gets terminated. Now, once P4 get terminated, you have the P1 and P2 still needs to be executed. So who will execute first? So since P2 is having the higher priority, so the P2 will execute first. So now you don't need to do one by one because you already know that it will always be P2 between two processes. So then simply you can just say like 5 plus 3, it will execute up till 8. And then the P1, the last process will execute up till 4 units of cycle, that is 12. Okay, so this is how you will draw your Gantt chart for the priority scheduling. Once it is done, you can calculate the completion time. So what is the completion time for P1? So it is 12. And what is the completion time for P2? It is 8. And what about like P3? So P3 is 4 and P4 is 5. Now, once you do that, you can calculate the turnaround time and the waiting time for the priority scheduling algorithm. So I have already like solved this. So for you, so you can just simply make a note of it and then you can verify the numbers. Now, the problem with this priority scheduling algorithm is it will suffer from drawback of starvation. So what is starvation? That means if you always have a higher priority process, then the lower priority process will not get executed. That means the lower priority processes have to wait for a longer duration of time for all the higher priority process needs to get executed. So if you see in this case of process P1, so the process P1 have to wait until all the 3 processes will get executed. It doesn't matter whether it's burst time, it only requires 1 and all the other processes say require maybe 9, 10 or 100 burst cycles. Still the process 1 needs to wait till all these burst times gets executed by CPU because of the priority. So this is where the starvation problem again occurs. So the starvation means where the processes will starve for the CPU. So on this note, let's wind our discussion on priority scheduling algorithm here. So thank you, everyone.